All right, for lab number 4, we're going to start off with a DAQ Assist. And to do that, I right-click anywhere on the screen, Measurement I/O, DAQ MX, and then DAQ Assist, and place it somewhere here. And then we're going to acquire an analog signal, and it's going to be voltage. And we're going to use the 2 channels, but I'm going to start off with channel 0. That's going to be my thermistor input. And I'm going to rename that signal to V thermistor. And I'm going to add a second signal. So I'm going to go to details. So V thermistor is on analog input 0. And I'm going to add a second channel. So add channel up here. It's for voltage and it's going to be analog input 1. Okay to that. And I'm going to rename that as well to V supply. Now I have them both named, and I just want to verify that they seem to be giving me the voltage expected. And yes, they are. So the thermistor and the supply are giving me expected voltages. Now we can move on by saying OK down here. And it should be that we're set up to be able to use this DAQ Assist. And the data coming out of the DAQ Assist is a dynamic data type. So one of the things I must do is come down to Express, Signal Manipulation, and add 2 of these from dynamic data type. And so I can put 1. But what's very important here is to make sure you select single scalar, and I've done that. And then I'm just going to click on it and press Control to make a copy of it, and double click on it. But this time it's going to be single scalar, but we want to select channel 1. Okay, that's one way of doing it. And I think if you hover over here, you may get the channel value. But what I prefer to do is actually right click on here and create constant, and that'll come up as channel 1. Same thing here, create constant, and that comes up as channel 0. Now we have to connect these 2 together to the output, and then also connect this to the dynamic type. And what this is telling me is that the data from channel 1 will come out of here, the data from channel 2 will come out of here. So let's add a couple of indicators, and they're going to be numeric indicators. So there's 1, and there's a second, and let's change them to an appropriate name. And we want to also set it up for 1 digit of precision. So we go to display format, select floating point, 1 digit precision, and turn off the hide trailing zeros. Same thing for the thermistor voltage. Down here to display format. And we can just go down here to 1, turn that off, select floating point, digits of precision. Okay, the next step is to connect those. So we come up here, and the supply is 1, the thermistor is 0. Connect these 2 together, and then we can test out this program. Okay, sorry that's not connected. Now it is. We run this program, go to the front panel, and you can see that we're getting 4.6 for the supply and 2.2 for the thermistor. On second thought, I'm actually going to change this so that we have 2 digits of precision for both of these. A little bit better precision. So display format, 2 digits, okay. The other thing is this program only ran 1 time. So something very useful to do for every program is to include a while loop. So I'm going to draw a while loop here. I might have made that a bit too big. Make it a bit smaller. Okay, so I want to be able to see the whole program, so I'm just going to drag this, and I do see everything now. The other thing I always do in my programs is add an indicator for the iterations, and I call it iteration. And then you must also have something that's going to stop the loop. So I right click, do create control, and that's going to be a stop. The only other thing is, notice this seems to be coming from above the stop. Well, right click on this and just do clean up wire. Clean up wire is a very important tool in LabVIEW. So now this is running in an endless loop. If we go to show front panel and click on run, when you have a loop, don't use run continuously. You should avoid using run continuously and use run instead. So my loop is running, my voltages seem to be okay. I'm going to heat up my thermistor, and that voltage seems to be going up. So that's fine. If you want to make these values a little bit bigger, you can select both of them. Go to Application Font, go to Size, and let's make it 24. And that's a little bit easier to read those values. If you want to make it bold, you do the same thing. Come up here, and let's even change the color. Let's make it red. And I might have not selected, so let's try that again. And color and red. There we go. And you could even make it bold if you want. So let's just show you bold. Oh, that's not what I wanted. It was style and then bold. There we go. So I have the supply voltage and the thermistor voltage. So that's the end of step number 1. In this next section, we are going to use a formula, and you can find that under Express, Arithmetic, and Compare, and then this formula box. Now, ahead of time, I've determined the formula required to be able to determine the resistance based on the supply and the Vin, and that formula is going to be, and I want to use all of the boxes in here, so it's going to be, well, we're going to create a label called V supply, and that'll be connected to X1, and the second label is Vin connected to X2. So I'm going to say the V supply minus the Vin, and then in brackets is going to also be divided by the Vin in brackets divided by 10,000, which is the resistance. Make sure you put the correct number of zeros, and this green light is just telling you that the equation is okay. There's no syntax problems with it. So now that I've done that, I have to remember that X1 is the supply, X2 is Vin, and the name is already given there, which is great. So now I have to connect this to the supply, which is right here. And I have to connect this to Vin. That's going to cross over. So actually, maybe what I'll do is, to save some time, I'm going to create a local variable. And you hit Control and B to remove broken wires. So I'm going to put this up here, down here. And I'm going to create a local variable, and you can do right click, go to Structures and Local Variable. And I'm going to put one here, and I'm going to do a copy. So I press the Control key, and notice that the arrow is pointing inwards, waiting to accept data, but we want to provide data. So it's going to be a source. So I do change to read, same thing here. Change to read, so I'm right clicking, change to read, and now I select the variable that I want to read from, and I have thermistor and supply. So the top one is going to be the supply, the bottom one is going to be the thermistor, and those are the signals coming from up here. I connect that to supply, and I connect this to, well, I'm calling it V thermistor. That's fine. It's just given a different name in the equation, but it's the same thing. And the result's going to be out here, so I can just create indicator, and that's the result. And the result is actually the resistance. So now that I've done that, let's just do a test that the resistance seems to be making sense. So I'm going to go to my front panel and run this, and my resistance is up here. And it should be about 10K at about 25 degrees. So it's reading 11K. If I heat it up with my fingers that are warmer than the outside air temperature, the resistance goes down. So that makes sense, and you can see that my thermistor voltage is correct. And so when it's about half of the supply, or about 2.3, this should read about 10K, because that means half the voltage is across the thermistor and half is across the 10K. So you see that's getting a little bit closer, 10.35, 10.34. It's going to be about 2.31, sorry, which is 10K. So all of that seems to be making sense. Okay, so I'm just going to double click on the formula again to show you the inside. Okay, and there's many ways you can do this formula, but the output is resistance. Hello, in step number 3, we're going to add the scaling and the mapping. And to do that, you right click on the screen, go down to Express, Arithmetic and Compare, Scale and Map, and let's place it somewhere on the screen. And what we want to do initially is to open a file that I'll provide on Brightspace. So click on Interpolated, click Define Table, and we can actually load that data. And that data happens to be called Lab4 Thermistor. It might have a different ending to the name, but it's called a LabVIEW measurement file. So double click on that, and it opens up what you see here. The X actually represents the resistance that it's receiving, and the Y, the temperature. So the temperature ranges from, I believe, 0 degrees to 100 degrees Celsius. These represent the temperatures. And as an example, you can see that at 25 degrees Celsius, you're getting a resistance of 10K on that thermistor. At about 30 degrees, 8K. At 20 degrees, 12.5K. So this is all making sense. And the next thing that we want to do is basically say OK to this. And it'll do the interpolation automatically. OK to that. And you have the resistance, which is the input to the scaling and the mapping. And the output is going to be the temperature. So I'm just going to do create. And actually, we're going to need to use an SubVI conversion. So that's in signal, sorry, not an input, but there should be, let's try that again. Go to Express, Signal Manipulation. Yes, I have the same problems that you have sometimes, that we need to select something, Signal Manipulation, and it's from Dynamic Data Type. So I put that there first, and we're using a single scalar. OK, and then we connect that to the scaled input, and the right, we click on Create an Indicator, and that's going to be the scalar representing the temperature. And I'm going to write down degrees Celsius. Okay, temperature degrees Celsius. And the next step is to actually test it out. So we'll click on this to say everything's okay. We'll go to the front panel, and there's my temperature degrees Celsius. We'll run the program, and it seems to be making sense for that resistance. I'm getting 22 degrees. Let's heat up the thermistor, see if that temperature seems to go up, and it does. So everything seems to be working as expected. The next part that we're going to add to lab number 4 is called a smoothing filter. And it's actually a type called a moving average filter, which I explained in theory. So to add that, you right click anywhere on the page, go to Express, Signal Analysis Filter, place it on the page. Since it's an SubVI, it opens up and allows you to configure the VI. So we're going to select smoothing, moving average, rectangular. That means each sample is equally weighted. And we're going to make the moving average half width equal to 10. If you make the number too large, it puts a delay in the data. And if you make the number too small, it won't filter correctly. So 10 is a good number for this particular application where we're trying to filter the signal from the thermistor. Okay, so make sure it says smoothing, moving average, rectangular, half width 10, and turn on signals. When all of that's done, select OK. Now we want to connect this filter to the output of our scaling and mapping. So I'm just going to bring this down to here. And since it's a dynamic data type, it just connects. And then we're going to add an output to look at the signal. So we need to actually go to Express, Signal Manipulation, and click on From DDT. So here you want to make sure, this is a really important part, that you select Single Scalar. And then connect OK. And then we can right click and say Create an Indicator. And we're going to give this a name, and we'll call it Filtered Temperature. Let's spell it correctly. So Filtered Temp. Now we can actually go and test this out. And you may not see a lot of difference here, but we'll go to the front panel. Here's the filtered temperature, and here's the temperature degrees Celsius. You won't really notice anything until I make a big and quick change. And you'll see they're sometimes not quite in step, but not too bad. Where you really will see the difference is when we add a graph, and that'll be the next step. Hello, in part 5 of the video, we're going to add a chart. So right click anywhere on the page, go to Graph and select Waveform Chart. Okay, we do want a chart and not a graph. They're slightly different. The other thing we want to do is change the scale. So this is a maximum of 30 and a minimum of 15. We do also want to make sure that auto scaling is turned off. And it is. We can go to Properties to see that. And you can see that the y-axis, you have to pull that down. And actually it is set to auto scale. So we're going to turn that off, make sure the minimum is 15, maximum is 30. And for the y scale, or the x scale, we'll fix this right now. Auto scale is turned off. And we want the maximum to be 1023. That's the maximum number of samples that we can see across the screen. So once we've set that up, and we can actually change the title to amplitude and time to 2 different values. So we'll go to Properties, and it says the name for the x-axis along the bottom. We're going to change that to samples. Okay, and on the y-axis, we can change it as well. And you'll notice there's a pull-down window for that, and we're going to say temperature degrees Celsius. Okay, much more informative. So we have temperature here, samples on the x-axis, temperature on the y-axis. The other thing that's very useful to do is that under the View menu, there's something called Tools Palette. It brings up this little palette. And as you move your mouse around, you can have it automatically change. And you can see that it changes to different things as you're moving the mouse along. So a crosshair, a pointer, sometimes it can be a hand, and these are all the possibilities, or even text when you want to put your name on the sheet, you can do that. But here I want to change the color of the waveform chart. So I select on this paintbrush tool, and it actually should open a menu showing different colors I can select. And I'm actually going to maybe choose a light gray, maybe this gray here, and then I touch it to the waveform chart and it changes that chart. But what's important is to automatically go into the auto select tool. That's where that's green. Then I can turn this off. So I've got a lot of the charts set up okay. I don't have both plots there. So now I'm going to go back into the block diagram and add some things to that chart. So that'll actually be in part 6. Hello, in part 6 we're going to add a cluster, connect our filtered and non-filtered temperature, and then set up the traces on the chart. So to set up the cluster, I'm going to go to the cluster and class, select bundle, put that bundle in front. And what a bundle is is it's a group of signals of different types. But in this particular example, it's going to be the same type. So the other thing I'm going to do is create a local variable for both the filtered and temperature in degrees Celsius. So to do that, I can go to Structures, Local Variable, and I can copy that. But before I copy it, I'm going to do Change to Read, because we want to read the data from that local variable. Now that I've done that, I just click on the Control key and I create a second local variable, and then you just click your mouse and select the filtered temperature. I want it to be on top, and for the second one it's going to be, you got to get your mouse so it looks like a pointer. We want to select temperature degrees Celsius. So we're going to bring these two into the chart. So the first thing I want to do is connect one of the inputs of the cluster and then the other input, and then once I've connected these two, I can connect to the chart. Okay, so I have that now connected, and it's important to make note that on top is the filtered temperature and on the bottom is the temperature in degrees Celsius. Okay, make a note of that because we're going to use it in the chart. So go back to the front panel and right click on the chart, go to Properties, and it's plots that you want to start with. So there's two plots that we're going to use, and you can see that there are two. Plot 0, which is the top one that we've connected, is the filtered temperature. So I'm going to change the name to filtered temp degrees Celsius, and it's going to change the top one, and it tells you that the line is going to be white, but I'm going to change it to red, and it's going to be a thin line. And then the second one I want to bring up is plot 1, and I'm going to change plot 1 to just temperature degrees Celsius. And this is the one that's not filtered, and we're going to make that one blue. Okay, now that I've done that, I should at least be ready to try it out. So I'm going to run my program. And you can see that the filtered one, which is in red, took a little bit of time to stabilize. And now if I heat up my thermistor, you can see that the blue one is the non-filtered. And it's taking a little bit of difference in time to respond. You can see that there's a bit of a delay, and it reduces the noise dramatically. You'll notice in this particular diagram that I only have filtered temperature being displayed. So I stop the program, and to add the second trace, I right click, go to Properties, and under Appearance you'll see that there are plots shown, and I only have one, so I want to have two, and I can see that they're both up there. I should be able to move this around. I thought I could just grab on to, let's see if I grab onto here. Now that's kind of a chart or an indicator telling you what's being displayed. Over here I can change this to Lab 4 traces. Okay, that's probably good enough. So everything's okay. I want to run it again. Okay, you'll notice that the blue line, which is the unfiltered, stays pretty straight, but the red line started off at 0. But now they're both following each other. But if I do heat up the thermistor, you see that won't be the case. There's a slight delay in what's produced at the output in red, and now it no longer has that noise. So it's now being filtered. Hello, this is part 7 of lab number 4. We're going to create a formula node as well as adding 3 controls. And these are controls that I created. So let's have a look at the controls. So we start by right-clicking anywhere on the page, and it says select a control. And I happen to have a file area that has these controls. So the first one is bulb on and off. and I'll place it here. The second one, and it's under controls, is I think deadband slider. Okay, and the third one is the set point slider. So select a control, I think it's under set point, and set point slider. Okay, and you can see that I've created other controls from various graphics that I either created or found online. But this one has a slider that says set point and deadband, so we'll make use of that. And it already has the deadband set to 1 to 3 degrees, and the temperature ranging from 20 to 32 degrees for the set point. So those are already created. And the bulb on and off is just going to indicate if the bulb that we're working with is turned on or off. So let's go back to the window, go to block diagram. And what we're going to now do is create a formula node. So we right click, and you'll see formula node here. We need to give us enough space. We might eventually have to move things out of the way or make the diagram a little bit bigger to give us room for that formula node. Maybe I'll move this down out of the way. And it's not going to be a very big formula node, but we're going to have 3 inputs: the set point, the deadband, and the filtered temperature. So to create those 3 inputs, we just do add input, and I'm going to call that set point. Create a new input, and we're going to call that deadband, and create a third input, and we're going to call that filtered temperature, just an abbreviation. And we're going to create one output, and we're going to call that heater out. Okay, and notice that they're all numerical values. I do want to show line numbers, so to show line numbers you just put line numbers there, and we're going to connect the filtered temperature, which is this one right here, to filtered temperature. And to do that, we're going to use a local variable. And remember, we want these to be inputs. So change to read, and we're going to create 3 of them. So let's just copy and paste these. And the top one is going to be the set point, and I have a set point slider. Okay, I don't have to wire this because I'm using a local variable. So set point, and this one's going to be the deadband, and this one's going to be the filtered temperature. And now we just connect these, and our program will use the variables in the boxes here, not the ones outside. These are the input variables, and this output variable, I'm going to add heater out. I'm going to add that input, call it heater out, and we need to add a feedback loop. And it's case sensitive, so I have to do that. And I'm going to add a feedback loop. And I forget where that feedback node is, but there it is right there. And it's going to connect from the output to the input. Okay, and then you'll see that there is another connection point here, or terminal. I'm going to right click on that and put control there. And actually I want it to be a constant. I want it to be 0. So I'm going to delete that, and then control B to get rid of errors, and then connect that. All that does is that when the program starts, the heater output equals 0. Now let's start writing my code. So all I want to do is when, and this is not going to be the same as your program, I'm just simplifying this, you have to write your own code, but it's going to be that if filtered temperature is greater than the set point, if that's true, I'm going to make heater output equal to 0. I want to turn it off. And if it's not true, or if filter temperature is less than the set point, in brackets, I want to make the heater output equal to 1. And notice that I have, well, actually I don't want to leave any space here, but otherwise I would have to use brackets. So if filter temperature is less than set point, which means it's too cool, then turn on the output. If it's not, then it's too hot. Okay, so I do need to have, and I'm just going to connect this to one of my outputs, but before I can do that, I want to control this bulb. But you'll notice that the bulb right now is a control. I want to change it to an indicator, just as simple as that. But I want it to be controlled by the heater output. So here I have to convert the numerical to a Boolean, and to do that, you right click, go to comparisons right here, and there should be something that says not equal to 0. So I'm going to put that here. So when this is not equal to 0, this will cause the bulb to change states. So I think we've got everything there to try this out. So let's give it a try. Show front panel. Ooh, we have an error. So if we click on here, it says formula node undefined variable. So let's go to show error, and it's somewheres in here. It may not be obvious, the error that I had, but when I try to run this, okay, it tells me that the error is on line number 4. Okay, so that's important to look at. And it has this crosshatch telling me that the error is very close to that. And I think it's because the if was in uppercase and it needs to be lowercase. So let me fix that. Okay, and I'm just going to go backwards. It's actually good to try that in this demo because I've actually had that happen many times with students. So let's give this a try again. Notice that it's not a broken run symbol. So now I'm going to run this, and I'm going to go to the front panel, and I'm going to set my set point to about 24 degrees. Doesn't really matter what my deadband is because the software is not using that right now. And the temperature right now is 22 degrees, so it's cold, so the heater is turned on. I'm going to hold the thermistor, which is going to cause my signal to change, and now the heater, once it gets under 24 degrees, should come back on. So 25, 24, watch this lamp. Should come on very shortly. There it goes. So everything seems to be working as it should. The next thing I'm going to do is add a select function so that we can have another trace going to my chart, which is down here. But let's first add that select function. So I believe it's under comparison. Yes, right here. I'm going to put it here, and I'm going to add this input is going to be control from the bulb output. I just have to properly connect it. And on my chart, I want it to go to my chart with one of two values, a lower number or a higher number. And I'm going to use 21 and 20. You might want to use something different depending on your chart. I'm going to create a constant and put, so if it's true, I want it to output 21. So I'm going to put 21 in that box, and if it's false, I'm going to create a constant and output 20. Okay, just move them out of the way. And then this is going to go to my waveform chart. Okay, now I only have two inputs to my waveform chart. So if I want to add another input, and this is where the cluster is important because now we're adding a different type. The other two were the double precision, and this is going to be Boolean. So I'm going to take the output of this. Sorry, this one's not going to be Boolean, but we could make it Boolean. So it's going to come into here and connect to there. But now there are going to be 3 traces in the chart. So now I have to go back to my chart. Okay, right click on the chart, go to properties, and I want to indicate that there are 3 plots on the chart now. And the bottom plot is going to be the heater on and off. So we have to go back to plots, and you'll see that there's a 3rd one called plot 2, but we want to change that to heater. And we'll call it heater on/off. Okay, a decent name. And maybe we want to make the line a little bit thicker, and it's going to be a green line. So I think we're good to go there. So let's just see what happens here. So we do have that green line, and we have 2 different plots, but let's actually take one of them away and change one to the set point. So let's go back here and show block diagram, and I don't want to include the temperature anymore. The filter temperature is what I want. So delete that, Control B to remove broken wires. And what I do want there is the set point. So I'm going to right click, go to structures, local variable, change it to a read, select which variable I want. In this case, it's going to be the set point. Connect the set point to the chart. Now in the chart, I'll probably want to change the label. So I'm going to go back to the chart, right click on the chart, go to properties, plots, and the first one was filter temperature, but this is changing. So we're going to change this to the set point. I'm not going to change the color, just going to change the name. And so now if you come back here and go to plots, you'll see it's filtered, set point, heater on and off. Okay, so let's try this again, and you can see I have the 3 names here. And we run this. Now the heater on and off. Let's do that again. So I'm running this, just doesn't seem to be running for some reason. It's not displaying on the chart. I think the reason it's not running is probably because the chart's not connected. So let's stop this and go back to the block diagram. And yes, when I made a change to the cluster, it disconnected from the chart. So be aware of that. I know it's happened to me a couple times. So go back into the run mode, show front panel, and now we're getting a signal. So the filter temperature is the red line, the set point is the blue line, and the heater output is the red line. So let's just heat up the thermistor and see if it follows my program. Yeah, that's called overshoot. I went way beyond here. Now when you run your program, you're going to have an upper threshold and a lower threshold. So it's going to be different than this. Okay, and in time that temperature will drop down. And like I said, I'm not using the deadband right now, but your program must use a deadband. Okay, and when I heat it up a little bit, okay, so this program has no hysteresis, no deadband. It switches right on that set point, but that's not a good type of control, so we want to add some deadband. But everything seems to be working okay. Now let me just show you some things again to remind you what's important here. Is that in the block diagram we had 4 inputs with the feedback node. That's important. And I'm just going to show a visible item label that's a formula node, and this one's a select. Let's add that visible item select, so that's fine. So everything seemed to work okay. This doesn't need to be that big, and you do want to have line numbers. Okay, so yes, everything seemed to work as expected. Hello, in part 8 we're going to look at SubVIs, probes, and tabs. And I'm going to start off with tabs. And tabs is a good way to organize your front panel. So right click on the front panel, go to layout. And there's actually horizontal and vertical splitters. You can have a look at that, and sub panels as well, but we're going to work with tabs. So I'm going to put a tab here. And so I'm going to add a tab. I might have backed up a little bit there, but you right click on the front panel, go to layout and put tab. I'm going to make the tab big enough for what I want to put into it, and then we're going to drag it over, and I'm going to set this up so that I'm selecting the position, size, or select button, and I'm not going to be in automatic mode. That way I can easily drag these into this first page. And I'm going to make all the inputs on that first page. I'll leave the output for later, and the voltage supply will appear there, and the voltage of the thermistor will appear there. And I'm going to call this inputs. So back to the front panel. I should be able to name this here. Now you may have noticed I wasn't able to change the names here, and that's because of the auto tool was not turned on. This thing wasn't turned on to change the text. So here I'm just going to call this inputs, and here I'm going to call this chart. So we can look at the chart or just the inputs. And actually, if I go back to inputs, let's add the resistance, the filtered temperature, and temperature degrees Celsius, and we can put the start and iterations here as well. Iterations and start stop. So basically have that in the first chart, and then on the second chart we're going to have the graph. So click on that chart. Okay, and there's nothing in there right now. I'm going to put the graph into there, and actually the output. And the output is here. So you want to make sure we're selecting this. And now we have just two tabs. Okay. Oh, I guess we can change them over here as well. Okay, so if I want the inputs, I go to here. If I want the chart, I go to there. That way it gives you, a big part of the page to put the chart. And when you're doing Lab 4, you want to make the chart take up as much of the page as you can. So this is the benefit of using tabs. You can have different parts of your program. And here I can make the chart take up quite a bit of the page. Okay, one thing I haven't added yet is the clear chart, and we're going to do that in just a second. So here the bulb is turned on and off, but let's go to the inputs. We'll run the program. So my set point is 24. These are my voltages, and I can heat up the thermistor, and you can see it's going up in voltage. These are my resistance values and so on. So let's go back to the chart. And since I heated up the thermistor, you saw that chart went way up there. So let's wait till it cools down. It's doing that quicker now. And as soon as it crosses that blue line, which represents, you can see with the menu up here, the blue line is the set point, the red is the filtered temperature, and the heater output on or off. So it's at 21 when it's on, it's at 20 when it's off, so it just came on there. If I heat up my thermistor just a little bit, okay, you can see that just as it's crossing that line, it's going to heat up and cool down, and the bulb is going to come on and off. And you can see the bulb on the lower right hand side as well. Now, one of the things that's a nice feature with LabVIEW is if you want to do some troubleshooting and you're running the program and you want to know what different variables are equal to, you can actually put a probe on the line. So I'm going to put a probe there. I'm going to put a probe at the voltage supply. I'm going to put a probe at resistance. I'm going to put a probe at the temperature in Celsius. And I'm going to put a probe at the select output and a probe at the bulb on and off. Okay, so now I can kind of watch what's going on, and let's see if I can put a double window here. Show front panel. Okay, I can show the front panel, and I'm going to execute the program. And now you see all of my variables that are being selected. Okay, so I can look at number 1, and sometimes it's easier to do within the block diagram. So I'm going to go back to the block diagram because it shows you where those probes are located. For example, probe number 1, which is, if I can find it here, right here, so the voltage of the thermistor. So it's showing me 2.1 volts. I'm going to heat up my thermistor. It's going to 2.2, 2 point so on, and right now the heater is turned off because it's too warm, but eventually it's going to come back on. So it's at 28 degrees right now. I think my set point was 24, but it'll show me when it does that switch. So right now it's false, but it's cooling down. It's at 25.2 right now. And it's the number 5 is the probe that's measuring the true or false to turn on or off the heater. So now it just came on, the probe went true. Okay, so the heater is now on. So I want you to add probes at some of those critical points in your diagram so that I can see everything working correctly. And you also need to have in your forms filled out to measure the voltages at different points. Okay, so I'm going to stop this. And one last thing I want to do here is to show you how to create a SubVI. So I might have to move some of these down so they're not in the way of what I want to create. And even this might have to come over and this up, because what I want to do is create a SubVI of the function that I have in the middle here. And to create that SubVI, I basically have to put a lasso around all of these components. And then I think I can go up here and edit. And it might be in file. I'm just not sure where it is offhand. Thought it was in edit. Yes, right here. So now that I've got everything highlighted, I want to create a SubVI of that program. And there you go. It just created it. So now I just have the inputs, okay, which are the filter temperature, the set point, and the deadband. And now I have a VI for that particular program. It's like a subroutine, very much like a subroutine. Let me just organize these a little bit better. I think the set point's down at the bottom, the deadband's in the middle, and you can actually open up this SubVI. I'm going to do that right now just to show you that. And if I double click on it, you can see I've created the inputs. And if I go to the block diagram, this is the block diagram. Okay, and now I can actually, I'm going to save that. That's my SubVI, and I'll call it Lab4 program. Okay, and then do OK. So it saves that, and one of the other neat features you can do is right click on this and actually double click, I think. Yeah, and see up here, that's the icon for that SubVI, but you can set icon to name. So it says Lab4 program SubVI. The other thing that you can do is on the left hand side,